This is the tech that got AI to be the best in the world at chess, Go, League of Legends, and even master autonomous driving. And today, I'm gonna show you how to set it up and actually run it on your home computer. And by the way, I'm partnering with NVIDIA on this video. They wanted me to put together this tutorial, and I thought it would be awesome to show you how to do RL locally. So how did this actually happen? How did AI surpass humans at all of these games? The answer is reinforcement learning. And now I'm gonna show you how to run it locally on your computer using NVIDIA and Unsloth. So previously, reinforcement learning took massive machines, sometimes millions of dollars to do. And now, thanks to RTX and your regular gaming PC, you can do this at home. So the specific type of reinforcement learning we're gonna be doing today is called reinforcement learning with verifiable rewards. That basically means that we are able to tell the AI when it does something right or when it does something wrong, but without us actually telling it. There is an automated way to do that, so humans are removed from the loop. And this is what makes it very powerful. You put the AI in an environment, it tests a bunch of things, it learns along the way, and then it figures out which of those approaches is best. This is what all of the frontier labs are using on their frontier models. So let's get into the specific use case we're going to be doing today. There's a game called 2048. It's a number game, it's a math game where you're trying to slide these tiles to create the number 2048, all while trying to prevent the board from filling up completely, which marks the end of the game. And so what we're gonna do is we're gonna take AI that knows absolutely nothing about 2048, and we're gonna use reinforcement learning to get it to become a master at it. So let's get into it. So there's a few things that we're gonna need to choose. We're gonna need to choose an open source model, and today we're gonna be using GPT OSS, which is the open source model from OpenAI. And then we need the reward function. And that is the function that says, yes, you got this right, and here's a point for getting it right, or no, you got this wrong, and now I'm gonna deduct a point from you. And I'm going to be using the RTX 5090, but you don't need the highest end graphics card to do this. It might just take a little bit longer if you don't. You can use any NVIDIA architecture to do this. I'll link all of the materials, all of the options, all of the instructions down below. And there are a number of ways to have implemented this, but we chose WSL Windows Subsystem on Linux because it seemed like the most straightforward after our testing. And yes, we did try all of the multiple ways. This was the easiest. And by the way, if you're not familiar with Unsloth, it is an incredibly popular open source repository with nearly 50,000 stars on GitHub. So the first thing is just make sure your drivers are up to date using the NVIDIA app. The next thing you need to do is download the CUDA files from the NVIDIA website. I'll drop a link down below for that. So come to this page, choose the options that are applicable to you, download the file, and then install it. Next, you're gonna open up your PowerShell or terminal. And then we need to download WSL, which is Windows Subsystem for Linux and Ubuntu. Basically, we're installing Linux on our machine, but in a containerized environment. To do that, wsl.exe-install space Ubuntu-24.04, hit enter. Next, we're going to load up Ubuntu. So we type wsl.exe-d Ubuntu-2404, hit enter. All right, next we're just gonna make sure it works. We're gonna type NVIDIA-SMI like so, hit enter, and let's see, there's the GeForce RTX 5090. And just to confirm WSL is working, we'll type that in, hit enter, and now we are in Linux. Now we have to install a Python environment. So we're gonna type sudo apt update, hit enter. All right, after you've installed the apt update, we're going to install Python 3. So sudo apt install Python 3 full, Python 3 pip, Python 3 venv-y. Again, I'll drop all of the commands in a document found in the description below. Hit enter. Next, we're going to spin up a new environment using venv. So sudo python 3-m venv unsloth env-rl. You can name it anything you want though. Hit enter. Then let's activate the new environment. Source unsloth env-rl /bin/activate, hit enter. And now you can see right here, our new environment is activated. All right, next we're gonna install Torch. So pip install Torch, Torch Vision, force reinstall index URL, and then the download URL. Hit enter. All right, it took a while, but it's now finished. All right, now we're going to install Unsloth, which is completely open source, completely free to use. So pip install Unsloth, hit enter. Once we have Unsloth installed, we're now going to install the Jupyter Notebook, and Unsloth provides us basically the entire process of what we need to do RL with this notebook. But first, let's install it. Pip install Jupyter. Hit enter. All right, next, we just need to start the Jupyter Notebook. So Jupyter Notebook, hit enter. And there we go. We have Jupyter running locally. All right, next we're gonna download the actual notebook. So we're going to go to the Unsloth website and I'm gonna show you where to click, but don't worry, down below in the description, I'll have the link to this page. So if we scroll down, we can see right there, GPT OSS 20B Auto Win 2048 game. Go ahead and click it. It's gonna open the notebook in Google Colab, but if you just hit file, then download, and you're gonna download the IPYNB file. And then once you do that, you're gonna switch back to your local Jupyter Notebook instance. And then from here, we're gonna navigate to where we just downloaded that. For me, it's the downloads folder, and then we're gonna open it. Let me show you. So here, downloads, and there it is. And this should open up the Jupyter Notebook for that recipe. Okay, so once we have this notebook loaded up, here it is. It's basically everything. And I'm going to walk you through it from a high level. All right. So you can skip this first block right here, this one. And that is done if you're running this in the cloud, but we're not. So just skip it. All right. So the first cell we're going to be running is this one right here from Unsloth, import fast language model, import Torch, and so on. What this is going to be doing is loading the raw model. Click into here. There is no play button, which is a little bit weird, but you just hit Control, Enter, and it will run. All right, and we know it's running because of this little star right there, and it'll turn into a number when it's finished. And remember, if anything breaks midway through, you don't have to rerun the entire thing. You just have to fix the step that you're on and then run that step. That's the nice thing about this notebook. And if you want more information, switch back to your terminal and you can actually get the log of what's happening. All right, and you can see there's a number there, so we now know it's done. All right, and the coolest thing about Unsloth and this notebook is it actually explains why it's doing certain things. So this next area, listen to what it says. To do efficient RL, we use LoRa, which allows us to only add 1 to 5% extra weights to the model for fine-tuning purposes. This allows us to save memory usage by over 60%, yet retains good accuracy. Okay, so let's run this same thing, Control, Enter. All right, that step's done. See the number 5 there. All right, now here comes the cool part. This is a variant of the 2048 game in this cell right here. And this was actually created by GPT-5. The Unsloth team didn't write the code for 2048, they simply had GPT-5 created for them. And that's gonna be important in a moment, so just keep that in mind. So that's all this is. This is an implementation of 2048. It is done through terminal, so it's all gonna be ASCII based, but you could easily add an interface on top of it. So we're gonna click into it, we're gonna hit Control Enter, we're gonna run it. It runs instantly because it's just a simple game. Here we go, we have a new game. Then let's run this cell. All right, at this point, what we're gonna do is just test out that our game actually works. So here we have the board. There's 2 and a 2 right there. And if they hit A, which moves it to the left, you can see the 2 should move over there. So let's hit enter and there we go. And then now we can test W. Then here we're testing D. We'll test W. We'll test D again. And so you can see the game is actually playing board state by board state. All right, now we're gonna set up our RL environment. So right here, we'll set up a function to accept some strategy that'll emit an action within WASD, the way to move the board around, and check the game state. We'll also add a timer to only execute the strategy for 2 seconds maximum. Otherwise, it might never terminate. Okay. So let's do that here. All of this should run really quickly because it's not actually doing the RL quite yet. So here it's saying, let's make a generic strategy to just hit W, which means just move everything to the left. Obviously, this strategy is not going to work and actually solve the game, but we should expect this generic strategy to fail. Let's do that. So now that one's running, timed out after 2 seconds. Okay, so that's testing for just 2 seconds. We can increase it to 5 seconds with the next cell. Let's hit enter, and there we go. All right, and then in this next section, these next few cells, we're basically just trying to catch any potential reward hacking, like changing the timer or allowing it to move pieces that it shouldn't. And that's what these next cells do. So same thing, we're just gonna hit Control Enter on each of these. It shouldn't take any time at all. All right, and this is kind of a unique way to do reinforcement learning. What we're gonna be doing is we're going to ask the model, our local model, for a strategy. We're gonna run the strategy, see how it does by using our reward function. If it gets a high score, we're gonna ask it for another strategy similar to that. And we'll run it a bunch of times, and hopefully what'll happen is we'll get to a strategy that beats the game. And all of that gets fed back into the model, so the model itself is learning how to beat 2048. So here's the prompt: create a new short 2048 strategy using only native Python code. You're given a list of numbers for the current board state, output one action for WASD on what is the optimal next step. Output your new short function in backticks using the format below. And then what we're gonna do is we're going to parse what GPT-5 tells us, put that into a function to execute, and then test it against our reward function. So here we're asking the model, GPT OSS, we're essentially just running inference, asking for a strategy. And we can see the actual output is running right there. And that's actually a decently fast speed. What is that? Probably 50, 60 tokens per second. And remember, it's on an RTX 5090 right now. All right, so I wanna point something out because this is super interesting. If you look here, it's clear that the inference just stopped. And what's interesting about that is this isn't valid code. So when it runs it, of course, it's gonna fail. And if you look up here, the max new tokens is 512, but that's okay. My inclination was, okay, let's increase the max new tokens, but the strategy should be able to fit within 512. So we're just gonna let it fail, and it's going to learn from that. All right, here is where the secret sauce of reinforcement learning with verifiable rewards comes in. These are the reward functions. 3 reward functions: function works, no cheating, and strategy succeeds. And we're going to design an extract function which extracts the strategy from the response from the model. So here, we just load up that strategy. Here, we're just gonna check if there are any errors. Here we see it failed, but obviously it failed because we talked about that. Here we're defining our function works method, hit enter. Here we're defining no cheating, and here is the strategy succeeds. Now the strategy succeeds, which says right here, checks if the strategy actually allows the game to terminate. So let's get that function set up. All right, now we're creating a data set with our prompt and everything else we need to iterate over this a bunch of times. So again, Control Enter, and now here's where the magic happens. So we're gonna be setting up GRPO and running it. These are just all the settings for GRPO. You don't need to change anything. If you wanna get fancy and you wanna play around with these, feel free, but that's for a more advanced tutorial. Same thing here, just getting it ready. And here is the execution method, trainer.train. And here we go. Okay, so I immediately think that there's something wrong, but we're just gonna give it a moment and see if it's running. It should be running. The star is still there. It did not fail. I can actually, let me pull this over. Looking at my GPU, it is definitely running. There it is at 53%, 58%. We see the temperature increasing, GPU goes burr. Okay, so we can see some output, and yeah, this is the part that's going to take a long time. We are using reinforcement learning to teach a model to be good at 2048. This takes a while. And we're gonna be doing it, as it says here, over 1,000 steps. Now, we might not need all 1,000 of them, but that's what the limit is that we're setting. Okay, so we have the columns output, but we don't have any rows yet. But let me point out 2 things that you should keep an eye on. Everything else you can not ignore, but look at it last. And actually, here we go. Just as I was talking, we have our first feedback. So first is the reward. Now we can see -1. It was a complete failure. So of course we got a negative score. If it succeeded and it did okay, we would have a better score than that. Now, if we scroll over to the right, we can see KL right there. And that tells us how different this new version is from the original model that we tested. And so it is not different because we're basically testing the first thing we got. And bringing this back, we can see my GPU is still running at 60%. And again, this is just gonna take a long time, so I'll be back. All right, it is finally finished. And this one took 84 iterations. Sometimes it'll take less, sometimes it'll take more. This one took 84, and you can see right here, all of a sudden we had this reward score jump to 10.5, which means it was very good. It solved 2048. So if we scroll down in there, we can actually see the board's outputting. So this one didn't solve it. Let's go to the next one. Here's another one. It got all the way up to 1024. Keep scrolling. And then if we scroll all the way to the bottom, there we go, 2048. So now we have a strategy that can solve 2048 created by the model, reinforcement learned to the model, and now the model knows. And now we can run the model again and it will just know how to do it next time. It has been changed and it has learned. So you can try it again down here where it says inference, but we've seen it, so I'm gonna skip that. And now last, we can save it, we can push it to Hugging Face, and of course you do want to save your model because you just put in all that work. So let me show you how much of an improvement this RVLR has given our model. Here is it basically failing 2048 before, and here it is acing 2048 after. It figured out the perfect strategy using reinforcement learning. Now, putting aside the learning time that it took my team to figure this out and for me to figure this out, the entire process probably took about 6 hours, and that is including the compute running. That is including the RL time. And the setup itself probably took under an hour. So it's actually quite easy. And so let me take a second to tell you, like, why are we actually doing this? Why is reinforcement learning cool? Beyond it just being cool. It's kind of a cool thing to do, to take this model and be able to train it to get really good at something. It's just a cool thing to do. But beyond that, there is actually a ton of utility there. In the future, as I mentioned, these models are getting smaller and more powerful, and we're going to be able to run more and more AI inference at the edge. That means on the devices you have in your home. And as that happens, you're going to want more control over it. You're going to want more customization. And so whether you're training it to do something fun like become an expert at 2048, or you're making it really good at understanding your personal life and giving you personalized responses back because it has all of your chat history, for example, and it's all very safe, very secure because it's all running locally. These are all reasons that having AI locally, doing reinforcement learning locally, doing fine tuning locally on an RTX is the way to go. So thank you to NVIDIA. Thank you to Unsloth for working with me on this. Hopefully this makes sense. If you have any questions, drop them below. We'll try to answer them. All the commands will be down below. All the documentation will be down below. So definitely check it out. And by the way, you can use the RTX GPUs you already have that you're using for gaming like I do, running League of Legends or Path of Exile 2 or whatever the game is that you're playing. That's the same exact GPU that you can use to do this reinforcement learning. And if you don't already have an RTX AI PC, of course, you can go pick one up. And remember, you can use reinforcement learning for a variety of different use cases. Here we used a game. You can do more complex games. You can do financial analysis. You can train it to drive an RC car, basically anything that has a verifiable reward. A way to determine whether it's a good outcome or a bad outcome can be done with RLVR. And by the way, I love working with NVIDIA. They've been a fantastic partner. We want to do more of these tutorials. So if you like it, drop a comment below. Let us know what else you want to see. Maybe a fine-tuning tutorial. Maybe we do reinforcement learning on something else than 2048. Anything is possible, just let me know. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.